Welcome to UpDegree SAS Predictive Modeling program. In our last videos, we had discussed about the concept of logistic regression, where we found that the dependent variable is binary in nature or dichotomous in nature, and the independent variables can be categorical in nature or continuous in nature. The dependent variable in logistic regression calculates the probability for y equals to event. So, just because the dependent variable calculates probability, therefore the value of the dependent variable lies between 0 and 1, where probability equals to 0 denotes an impossible event, probability equals to 1 denotes a sure event. We had also discussed about the standard form of logistic regression equation, that is standard form of logistic regression model, the curve which represents logistic regression, that is it's a sigmoid curve, the different assumptions of logistic regression, the different applications of logistic regression. We had discussed about the key differences between the linear regression and logistic regression, the goodness of fit test to check how good is our model fit for logistic regression equation model. We had discussed about Hochman-Lemche goodness of fit test, where our null hypothesis is the model is a good fit and our alternative hypothesis is the model is not a good fit. So if our p-value is greater than our level of significance, then we will accept the null hypothesis, that is the model is a good fit. Now in this video, we will be discussing about the concept of odds and odds ratio. Now what is odds? Odds is the ratio of probability of an event divided by probability of a non-event. Mathematically, it can be represented as odds equal to probability y equals to 1 divided by probability y equals to 0, where probability y equals to 1 denotes probability of an event and probability y equals to 0 denotes probability of a non-event. So this is the standard form of logistic regression model, that is equation, the standard equation for logistic regression model, where probability y equals to 1 is equal to 1 by 1 plus exponential means e to the power minus beta naught plus beta naught or b naught plus b1 x1 plus ei, and probability y equals to 0 is 1 minus probability y equals to 1, which is equal to 1 by 1 plus exponential, that is e to the power b naught plus b1 x1 plus ei. Here we have considered that there is one independent variable, that is x1, b naught are the intercept, that is b naught is the intercept, and b1 is the regression coefficient, and ei are the error terms. Now based on the standard equation for logistic regression model, if we calculate the odds, then we get the equation for odds, or the expression for odds is e to the power b naught plus b1 x1. If we do not consider the error terms, and if we want to consider the error terms, it will be odds equal to e to the power b naught plus b1 x1 plus ei. Here we have not considered the error terms while calculating odds. So therefore the expression for odds is equal to e to the power b naught plus b1 x1. Now if we take the natural logarithm on both the sides, that is ln of odds gives you b naught plus b1 x1, that is it's a linear model. So this is the assumption of logistic regression which we had discussed before, that there is a linearity between the independent variables and log of odds in logistic regression model. So that assumption got clarified in this derivation, that if we take natural log on both the sides, we get a linear model. Therefore ln of odds is equal to b naught plus b1 x1. Now let's understand the concept of change in odds. If we change x by 1 unit, then the change in odds is given by, see, odds x is equal to e to the power b naught plus b1 x. If we increase the value of x by 1 and makes it, and the value of x becomes x plus 1, then the expression for odds becomes e to the power b naught plus b1 into x plus 1. Now if we find the change of odds, then we'll find that the new odds will be e to the power b1 times the original odds. So if the value of my x increases by n times and it becomes x plus n, then my new odds will change by e to the power n b1 times. So this is a very important derivation. You can understand that when we increase the value of x by a particular term, say it is n, and our independent variable becomes x plus n from x, that is our independent variable changes from x to x plus n, then our new odds will be e to the power n b1 times the original odds. Now let's come to the concept of odds ratio. Odds ratio is basically the ratio of two odds. In order to explain you all the concept of odds ratio, let me take an example. Here we have assumed a case where the probability of y equals to event is that accident will occur, that is the person is going to get hit by a car, and probability of non-event is, that is probability y equals to 0 is accident will not occur, that is the person will not get hit by a car. Now I have divided the individuals into two parts. One is poor vision individuals, another is good vision individuals. For poor vision individuals, probability y equals to 1, that is the accident will occur, is going to be equal to 0.7. Let's assume, we have assumed that probability y equals to 1 for a poor vision individual is 0.7. Therefore, probability y equals to 0 for a poor vision individual will be 0.3, that is 1 minus 0.7, because probability y equals to 0 is 1 minus probability y equals to 1. Similarly, for good vision individual, probability y equals to 1, that is probability y equals to event, which denotes that accident will occur, is equal to 0.4 that we have assumed. Then probability y equals to 0 will be 1 minus probability y equals to 1 for good vision person, which will be equal to 0.6. So see, for a poor vision person, my probability y equals to 1 or probability of an event is 0.7. For a good vision person, probability y equals to 1 is 0.4. So for a poor vision person, probability y equals to 0 will be 1 minus 0.7, because some of the probabilities are equal to 1. So 1 minus 0.7 is equal to 0.3, and probability y equals to 0 for good vision person will be 1 minus 0.4, which is equal to 0.6. So odds for a poor vision person will be what? Probability y equals to 1 by probability y equals to 0. So odds for poor vision person is 0.7 by 0.3, that is 7 by 3, which is approximately equal to 2.33. And odds for a good vision person will be again 0.4 by 0.6, that is probability y equals to 1 by probability y equals to 0, which is 0.4 by 0.6, which is equal to 2 by 3, which is equal to 0.67. Now odds ratio is ratio of two odds. So either we can do poor vision by good vision, or we can do good vision by poor vision. Here I have done poor vision by good vision, which is equal to 2.33 by 0.67, which is equal to 3.48. Approximately we can take it as 3.5. So the interpretation of odds ratio is, if I am moving from a good vision person to a poor vision person, then the odds of getting hit by a car increases by 3.5 times. And if we take the reciprocal of it, that is, if we do odds good by odds poor, then the interpretation will be, when I am moving from a poor vision person to a good vision person, the odds of getting hit by a car will increase by 0.3 times. So now let's understand the interpretations of odds ratio. Odds ratio is basically the ratio of two odds. Odds ratio helps us to understand the effect of a predictor. The interpretation of the odds ratio depends on whether the predictor is categorical or continuous. When the predictors are categorical, that is when my independent variables are categorical, for categorical predictors, the odds ratio compares the odds of the event occurring at two different levels of the predictors. Odds ratios that are greater than 1, for say there are two different levels, say level A and level B. So odds ratio that are greater than 1 for level A indicates that the event is more likely to happen at level A. And odds ratio that are less than 1 for level A indicates that the event is less likely to happen for level A. Similarly for level B, and if we want to understand the concept of odds ratio for continuous predictors, odds ratio that are greater than 1 indicates that the event is more likely to occur as the predictor increases, and odds ratio that are less than 1 indicates that the event is less likely to occur as the predictor increases. So in this video we will be learning till here. Before I move to the next video, let me recap the concepts. In this video we had discussed about odds and odds ratio, where odds is the ratio of probability of an event divided by probability of a non-event. We had derived the expression for odds, that is e to the power beta naught plus beta 1 x1, and we had also calculated that how our odds will change if we increase the value of x by 1. So if we increase the value of x by 1, or say if we increase the value of x by n and the value of x becomes x plus n, then our new odds will be e to the power n beta times of our original odds. Then we had also discussed about that if we take a natural log of odds on both the sides, we get a linear model. That is, the assumption of logistic regression model got clarified, that there is a linearity between the independent variables and log of odds in logistic regression model. We had discussed about odds ratio, which is the ratio of two odds, and we had also discussed about the interpretation of odds ratio, that is the interpretation of odds ratio for both the continuous predictors and categorical predictors. Now in our next video we will be discussing about concordant pairs, discordant pairs and tight pairs, and what are the steps that we need to follow to calculate concordance or discordance. For now, let's end this video over here. Goodbye. See you all for the next video.